Good afternoon. Welcome back to Claris Engage. This is Big Dig Episode 2. I am Salman Sheikh from SmallCo, your host for this presentation. I also have on the line Albert. Albert, say hi.
Hi, how you doing?
And also we have Milan. Milan, say hello.
Hello, guys.
We are here to speak about one of the other parts of Big Dig, how we handle data coming in through APIs using an ETL process. Of course, this is a picture of me, and behind me is Jamie, and behind him is Milan taking a picture of the Atlantic. A little bit about me. I am a dad who tells really bad dad jokes. This is my youngest. She has picked up my sense of humor. For many years, I was a FileMaker guy on the landscape, running my own shop, and now I am with SmallCo. Very much enjoying my time here. And these are some of my colleagues at SmallCo. To my immediate side is Dave. Hopefully he shall join us during this presentation. Jamie again, and Milan again. We hope that as you watch this presentation, you like what we have done. Hopefully you will say an ETL process like this could work in your environment.
So I'm kind of quoted here, so maybe I can say it for real. I'm big on the notion of typing things, even if you don't have to, right? So FileMaker is a platform where it is not strongly typed. It's very permissive in its data typing. And then in many other ways as well, you're free to define your own types or not as you're coding on this platform. It's one of the strengths of FileMaker, but it does help organize your thoughts if you type your integrations. So I've asked the team to consider that within the Big Dig, anytime that we're dealing with what I call an asymmetrical API, then we should consider using ETL. And we did. So that what we actually did here is find a way to use the same exact file as a basis for at least 4 different integrations. And so let me explain what I mean by an asymmetrical API. There's much more data that's headed into this central file than is going out. You know, this little green arrow can represent, keys, just very, very basic information that's sent out just so that we can get data returned in that is set to be kind of staged and batched and poured into our current solution. And it's the same over on the other side, where we have data that is leaving from the Big Dig, heading out to our accounting package, or out to this really cool module that Milan built that deals with work chat. So we're sending messages out to Slack, Flip, Microsoft Teams, etc. Much more data is heading out than heading in, and it's heading out in batches. So for that reason, ETL is appropriate. It's not always appropriate, but when it is, it's pretty darn cool.
As we worked with APIs, we found the data flows are very interesting. And working with a process that we're about to describe, it helped us to organize and create a structured system. To give you an idea of some of the systems we are working with, we've got data coming in from Expensify, we've got data going out to QuickBooks, and in particular, in course of this presentation, we'll speak to the telematics data coming from the heavy equipment vendors, Komatsu and Caterpillar. In episode 3 of this series, Otto will speak about the walk-around checklist he and Anya built. That is not so much powered by APIs, but it is a very interesting presentation. I highly recommend it. As we were developing the Big Dig, a bit about our process, we created the goal spec. To be fair, you would have at this point seen Hazel's episode 1 about creating the goals and roles that she and Jana and Roz came up with. And this is episode 2, where we speak to some of the highlights of the coding and working with the data and the APIs. And of course, after you develop your application, you have to test. And once it passes your testing, you deliver to your client. And for us here at SmallCo, Albert is, of course, our founder and our leader. His daughter, Jana, and his goddaughter, Hazel, also manage. And Susan Allred-Prosser has joined us quite recently. So that is an exciting development for us. End chapter 1. Shall we get into working with the data under Big Dig? This is the job card that you would see on the front face of the application. You'll notice it speaks to, in particular, the machine name and some of the data elements that come underneath it. You'll notice things like the orometer reading, the number of hours the machine has operated, and you'll also notice that number that is being highlighted right now is the orometer reading. And that is one of the more important readings that comes off of the API. We're very proud of that.
And Salman has this data coming in at this moment. In other words, the machine is turned on, the orometer reading, and then chapter 3's discussion of the checklist is also integrated here. The fact that the checklist was done, as well as other data placed here by Anya. There's a really fun little sideline here. Some folks are interested in, well, what are the dangers in staging data? Turns out there are a couple.
Many of us had this in a real life scenario with our data, I'm sure. And so the ETL stands for extract, transform, and load. As we worked with APIs, we found it became easier to extract from the source, transform as we needed to in place, and then load it back. Because we started to apply it as a process, we found we could run it at scale instead of having to do each one as a custom job the way that FedEx driver did. So as we were working with the equipment telematics, on our first pass, we hard-coded so much of the information of the APIs into scripts, into the underlying tables, the layouts on the UI. And at the time, we were pretty happy with it. We sat back and we said, this is good. But as we, this is a diagram of what the ETL, of what the graph looked like as we finished. It's not how we started, but we hope this speaks to you. We'll speak a little about the extraction at this point. We thought it was robust. We thought it was good. We thought we were happy. And around this time, Albert got very much into a Nassim Nicholas Taleb kick about making systems anti-fragile. And just that minute, as we started working with Caterpillar APIs, they had 27 different APIs. Now, at some point, we are techies, and we'll slog through all 27. But at some point, you have to say there's got to be a better way. There's got to be a way to run this at scale. Because if we were to do each one by one, if there was the slightest bit of change, it would break the entire system. Or if we're lucky, the whole system. And it wound up being fragile for our purposes. So we needed to make a system that would be much more anti-fragile. And of course, the definition of anti-fragile is a system that keeps getting shocks, that keeps breaking. And at the break points, it gets stronger after that. So you'll find that it starts as fragile, it starts as robust, you think it's fragile, and as you keep iterating, you'll achieve anti-fragility. So for us, how do we code for this? Well, we had to go back to the drawing board a little bit, and so much of what we had hard coded, we had to pull out of scripts. We had to pull out of things like that, and actually make a database record out of many of these things. The URL, if a token was required, any credentials that need to be put in. The token itself we would store. In any and all attributes that come from that API, we started to embed in the database record for that API. And it got to be fun because we could add an active-inactive flag to the record, and we could take it out of circulation if we needed to. So what wound up happening is the extraction did not get more complex as part in regards to the underlying database. It looks pretty much like this. So on the one side you have, the record of the APIs themselves, and we log the heck out of it as for each API call as it runs. With that, we could troubleshoot much more easily along the way because we were recording each API call. We can look for the errors after the fact much easier, and we can get alerted for errors after the fact. It started complex, and this is a view of what it looks like. So literally, you can see the attributes from the API itself. So as we could transform on the fly as well. We've got the attributes listed, as you can see, and our next step was working with the underlying database. We would populate a staging area within the structure with all of these attributes. And we thought it was pretty good. We kept working with more APIs. We needed more hard-coded data fields for the data coming in. And as we looked at it, we felt we'd almost painted ourselves into a corner because we'd taken on a level of technical debt where we had increasing fields in the staging area that were used one-off for APIs as they were needed. Again, we had to deal with that piece of fragility because we had fields that just kept growing and some got abandoned and new ones were created. So we went back to the drawing board this is our transform version 1. I was very happy with it at the time. And as we went back to the drawing board for version 2, we thought, we've got these attributes listed coming out of the API. Why don't we use the same arrangement and dictate what fields they should go to in the staging table? And Albert, if you can pan to the side a little bit. Thank you. Here you'll see where we started to denote where the data should go in these fields. So we had on version 2, we had an even better idea. What if we don't hard code database fields this time? What if we generate them on the fly? Is that even possible in a database where we're used to hard coding everything? So our idea was to flatten the transform area. And Albert, if you can go to the next slide. You can see here we flattened it by making even the attribute name itself variable.
But down here, right? This one here.
Yes.
So you have basically name value pairs, attribute value pairs are split into each record.
Instead of hard coding, having a hard coded database field for the attribute, we write it on the fly.
I mean, the thing to
And
remember is that this is like a Rosetta Stone, right? Because you don't really know how different Caterpillar and Komatsu and John Deere and Volvo can specify the same data points. So you have to stay very far from, you have to get really abstracted from their particular forms, however their JSON comes across. We're dealing with XML and even at times scraping emails, right? So put that way over on one side and then just get your attribute value pairs on this side.
And you'll notice as you look at our script, the heart of it becomes an inner loop. The outer loop, of course, running between APIs. The inner loop is a couple of evaluate fields where it writes to the flattened table. It loops through the list of fields as you saw earlier and writes to those flattened fields. So we were quite proud of that. So what wound up happening for us, dealing with all of this fragility that we hit, we trying to make our system much more robust. We now have a flattened table with only the most recent data because it overwrites as it needs. And then we also have a table showing historical data where it increments as it goes, where it keeps writing through the table with all of the database fields. You might hear of this in other coding languages. They call it dry versus wet, where you don't repeat yourself. Because if you notice in that script, we did not keep repeating scripting and just changing the field name. We loop through variable names. And so as you're working with this ETL process where we've systematized working with multiple APIs, we'd like to think we're closer to anti-fragile than we've ever been before.
I had no idea the benefits that would really come from me pushing in this direction. But you guys are brilliant. You took some kind of half-formed, half-baked, half-cheeked formation that I gave you, and you found a really awesome way to implement it. So I'm really very thankful and proud of you guys for what you did, and worked out good for me because otherwise you would have come after me with sticks.
Well, maybe if they were repeating fields.
Thank you, Albert. Thank you very much. And now to speak a little bit about loading into the big dig.
Just in case you were not going to mention the fact that these table occurrences are in italics. So that's kind of big news, right? Because everything else has been not italics so far. These are all local to our satellite table. And now the stuff is getting pushed into the heart of the app. So kind of an important transition.
Important transition, yes, thank you. We wind up with two possibilities now to push data into the big dig. We have, of course, a very traditional mount table occurrences and write data into big dig using traditional FileMaker development techniques available to us. That has the benefit, of course, of static data in static fields that can be pulled in the application as needed. And it becomes available in any scripting that is needed in the application and can be available on the UI as needed. The other one that becomes available to us is because we have all of this data available in the ETL module. You can query it on the fly using a series of SQL scripts. And you can see a couple of examples here where you can generate a list of machines on the fly and then turn around and use it to see what attributes are available in the ETL module on the fly. And then you can query for the value in those attributes on the fly. And of course, this part is a lot of fun. You can also get historical data for those attributes. Now, something like this is very interesting because for parts of the ETL module, we stepped away from hard coding things. So if an attribute becomes available from an API, we push it all the way to the staging tables. In an arrangement like this, it becomes available to the application on the fly. And if there is a reporting module generating graphs of some sort, showing, for example, a geomap with locations, or a timetable of on and off times, that data can populate on the fly in the UI. So a great many things are possible now that weren't before using this kind of an arrangement. And of course, this becomes our arrangement for our ETL module. A couple of simple tables where at one time it was far more complex and far more hard-coded. So this was our presentation on rapid deployment of APIs and how we abstracted them to be able to add them faster to our application. We hope you liked our part 2 of this presentation of the Big Dig series here at Claris Engage. Some of the other parts to look for. In part 3, you might see bits of the job card and the waybills. You might see a bit of the time cards. Oh, sorry, part 1. Yes, you're right. But the big one in episode 3 is, of course, going to be the walk-around checklist that Otto built using React Native as the front-end client in FileMaker's database as his back end. It's really quite exciting.